Here we first explain the diagram, and where we can consider O as the object. Here from this point, the ray of light incident on the spherical surface, and it reaches at the point I, and we can consider I as an image of the object. Here in this picture we can say C is the center of curvature of the diagram, center of curvature of the spherical surface also. So here we can consider ON is the angle of incidence, ray of incidence, and NM can be considered as the perpendicular to the principal axis, because we consider the aperture NM is very small, so we can consider the small angle approximation into this case. So when we consider such situations are the basic of this diagram, we can say that angle u distance u is the object distance, and the distance v is the image distance, and the distance r can be considered as the radius of curvature from this figure. So here we can consider at least three right angle triangles, so that we can consider angle NMO as first triangle, angle NMC as the second triangle, and angle NIM as the third triangle. And where first medium can has a refractive index of n1 and second medium has a refractive index of n2, then we can write the side relation or trigonometric relation for these triangles mentioned above, that is tan angle NOM is equal to MN by OM, and tan NCM is equal to Mn by Mz, and tan angle NIM is equal to Mn by Mi. So that we can consider triangle NOC is for this triangle we can consider I as the angle I as the exterior angle. So we can say that angle I is equal to angle NOM plus angle NCM. So when we consider this case, you can write using the above relation of trigonometric relations. We can write I is equal to Mn by OM plus Mn by MC. For small angles, we can consider tan angle NOM is equal to angle NOM itself. And similarly, angle NCM is equal to tan angle NCM is equal to angle NCM itself. So we can write this relation. Similarly, when we consider the triangle NIC, we can consider angle NCM as the exterior angle, so that we can say angle NCM can be used to write the expression for angle angle of refraction relation. Therefore, angle of refraction R is equal to angle NCM minus angle NIM. That is can be written as R is equal to Mn by Mc minus Mn by Mi, using the first three relations. So this can be considered as equation number 2. Using equation number 1 and 2, we write before connecting these two equations, we write Snell's law. Snell's law can be write as n1 sin I is equal to n2 sin r. For small angles, sin I is approximately equal to I, and sin r is approximately equal to r. So we can write, instead of sin I we can write I. So we can write n1 I is equal to n2 r. So this relation is useful in connecting I and R, so that we know that we can use the above equation number 1 and 2 equations in this equation, so that we get a relation between I and R. Instead of I and R, we can substitute those values. So what we get is n1 into Mn by OM plus Mn by Mc is equal to n2 into Mn by Mc minus Mn by Mi. So when we substitute this equation, we can write in all these equations, left hand side and right hand side, we can say Mn is common, we can take it outside or cancel it, so there is no Mn in this term, and we write n 1, if we multiply this n1 into 1 by mc, we can take it this 1 by n1 by mc to the right hand side. So we get minus n1 by mc, and from the right hand side of this equation, n2 by m1 m2 by mi, we can take it to the left hand side. So it will become n1 by om plus n2 by mi is equal to n2 minus n1 by mc. So this is our third equation. So when we use this third equation, we can apply our Cartesian sign convention. That is, om can be considered as minus u, mi can be considered as plus v, and mc can be considered as plus r. So when we use this relation, we can write this equation n2 by v minus n1 by u is equal to n2 minus n1 by r. This is our equation for n1 connecting n2 v u r. So this relation says the how refractive index is related to angle of refraction and object distance and image distance. So this is very useful to derive our lens makers formula.